Now let's discuss about bridge pattern. The bridge pattern is a design pattern that allows you to decouple an abstraction from its implementation so that both can vary independently. This pattern falls under the structural design pattern category. The main purpose of using the bridge pattern is to separate the implementation details from the client code. It is particularly useful when we need to extend the functionality of a class in multiple dimensions or when we want to have interchangeable implementations. By using the bridge pattern, we can easily modify and extend the code without impacting the rest of the application. Now, let's look into the code example. This code demonstrates the bridge design pattern, which is used to separate an abstraction, high-level component, from its implementation, low-level details, so that they can vary independently. In this case, the code models a payment system using TypeScript and the bridge pattern. Let's break down the code step by step. This defines an interface payment processor that represents the abstraction for payment processors. It requires implementing classes to have a process payment method that takes an amount parameter and returns nothing, void. This sets the contract for payment processors. This is the first concrete implementation of payment processor named Online Payment Processor. It implements the process payment method, which logs a message about processing an online payment and may contain actual online payment processing logic. This is the second concrete implementation of payment processor named Offline Payment Processor. It also implements the process payment method, logging a message about processing an offline payment and potentially including offline payment processing logic. This defines another interface payment gateway that represents the implementer for payment gateways. Like payment processor, it requires implementing classes to have a process payment method. This is the first concrete implementation of payment gateway named PayPal Payment Gateway. It implements the process payment method, which logs a message about processing a payment via PayPal and may contain the actual PayPal payment processing logic. This is the second concrete implementation of payment gateway named Stripe Payment Gateway. It also implements the process payment method, logging a message about processing a payment via Stripe and potentially including the actual Stripe payment processing logic. The payment class represents the abstraction that bridges the payment processors and payment gateways. It has a protected property payment processor of type payment processor, which is initialized through the constructor. The process payment method of the payment class delegates the payment processing to the selected payment processor by calling its process payment method. In the client code section, instances of different payment processors and gateways are created. Two payment objects, online PayPal payment and offline Stripe payment, are also created, each initialized with a specific payment processor. Finally, the process payment method is called on these payment objects with different amounts, demonstrating the usage of the bridge pattern to process payments with different combinations of payment processors and gateways. In summary, the bridge design pattern, which facilitates the separation of an abstraction, in this case, payment processing methods, from their implementation details, payment gateways. By employing interfaces and classes, the code enables flexibility and extensibility in the payment system, allowing different payment processors and gateways to vary independently. This pattern helps maintain code modularity and scalability while ensuring that the client code remains unaffected by changes to the underlying payment processing logic.